Today, I would like to share a groundbreaking paper named ReAct, Synergizing Reasoning and Acting in Language Models. The paper was accepted at ICLR 2023 as an oral presentation. In this paper, the authors propose a novel way to merge two exciting capabilities often studied separately, reasoning and acting, within large language models. The authors have shown impressive capabilities of large language models on various tasks, even when the models are prompted with only one or two in-context examples. Let's now dive into the specifics of ReAct, its results, and broader implications for the field of AI. First, I would like to provide a brief introduction and motivation behind ReAct. Then, I would like to provide the mechanism of the framework and how we can synergize reasoning and acting by just prompting. We then see how this technique is applied in different tasks, knowledge-intensive reasoning tasks, and decision-making tasks. Lastly, we provide brief overview and key takeaways from the ReAct framework. The abilities of large language models on reasoning and acting have been well studied over the last few years. For reasoning, we can prompt the model to think step by step, think what to do next, or think about the past. We can prompt the model to search, perform an action, or provide an answer. A few prominent examples of reasoning and acting are chain of thoughts or SACAN. For reasoning, the chain of thoughts technique allows model to think step by step before arriving at the final conclusion. For acting, SACAN provides a contextual grounding for robots to perform only actions that are feasible in the current environment. Both approaches achieve a surprisingly good performance. However, it doesn't reflect how humans adapt to a new problem. Let's consider the following scenario. Suppose you are given hard homework that goes beyond your ability. What should you do? Can you miraculously think step by step and come up with the final answer? Assume that probably the whole is beyond your ability. If you can figure out every single problem by thinking step by step, then we no longer have any problems in the world. Or can we ask our knowledge to help with the homework? Knowledgeable TA, they may provide some hints, or even solve the homework. But you must be the one who do the homework. Scenarios. Humans tend to perform reasoning and acting in an interleave manner. We seek for help, then we think about the problem, and repeat the procedure until we come up with the final answer. ReAct allows to model such a behavior for large language models. Reasoning traces provide internal knowledge for language models to perform actions, and observations from the environment allows us to enhance our reasoning. Is indeed very simple. The key idea is to explicitly introduce thoughts into reasoning without performing any actions. It is similar to how humans think in their minds before doing something. Good thoughts allow us to perform more responsible and reliable actions. Next, we will see how it works under the hood for different tasks. Let's start with a multi-hop question answering benchmark called Hotpot QA. Specifically, the model can only access to questions and must rely on internal knowledge or retrieve external knowledge to come up with the final answer. As shown in the above example, a language model is asked to provide the other device that can control the program Apple Remote was originally designed to interact with. The model can't come up with the right answer by answering directly, step-by-step thinking, or information retrieval only. The reason-only baseline suffers from misinformation, while the act-only baseline can't provide the correct answer. However, ReAct allows the model to interleave reasoning and acting similar as human by combining multiple thought-action observation steps and free-form thoughts. The technique allows model to have an interpretable reasoning traces and is grounded with both internal and external knowledge. To further mimic human search actions, the authors provide a simple Wikipedia API to search for sentences and look up for words from passages available on the internet or finish the current task with an answer. The authors find that ReAct plus chain of thoughts self-consistency perform best for prompting language models. Specifically, we can flexibly switch between techniques after certain steps to ensure the balance between internal and external knowledge. It is similar to how humans try to repeat the same action for certain times before switching to a different approach, then come back again if that new approach is not effective for other problems. Furthermore, ReAct with fine-tuning achieves state-of-the-art results on the Hotpot QA benchmark, which is highlighted by the red columns. Consider the AlfWorld benchmark, which is a synthetic text-based game. The game requires the language model to plan, achieve subgoals, and explore environments. As shown in the example, the act-only baseline suffers from hallucinations and has trouble to understand the environment. With ReAct, the model can successfully achieve the task by invoking sparse thoughts along with actions. To prompt the model, the authors annotate 3 trajectories from the training set for each task type, where each trajectory includes thoughts that decompose the goal, determine goal completion, and the next subgoal. Reason by a baseline model butler on 5/6 tasks. The number in the table is the success rate. Conclusion, ReAct is a novel prompting technique that incorporates both reasoning and acting. ReAct is intuitive and easy to design, as it imitates humans' thought process without further ad hoc designs. ReAct is general and flexible. It is demonstrated via different tasks ranging from question answering to planning. ReAct is performant and robust. It shows an impressive generalization capability on new task instances and achieves state-of-the-art results. Human-aligned, ReAct is controllable. It demonstrates step-by-step thoughts or decisions, which allow humans to fact-check if necessary.